Here is a quick review of the basic concepts in demand. Demand represents the buyer side of the market. This is probably the side of the market that you have the most familiarity with, right? Because you're used to purchasing things much more so than selling things probably. And so there's going to be a lot of intuition that you've got. We're just trying to add some formality to the story. A definition: demand, when an economist uses the term demand, what do they mean? They're describing an inverse relationship between two variables, two things that we can measure. One thing is the price. The price represents how much buyers have to give up in a transaction in order to get goods or services. And the other thing that is measured is this concept of quantity demanded. Quantity demanded is a measure of how many units buyers want to purchase. Quantity demanded is the number, it's the count. You want to buy 5 subs, you want to buy 10 cars, you want to buy 3 doctor visits. When we count up something that buyers want to purchase, we're measuring quantity demanded. Price, amount of money that they have to give over, and demand is a relationship between those two variables, right? So I can divide these through. Quantity demanded and price are measurements of a single concept, whereas demand is talking about a relationship between these two concepts. Graphically, demand is a downward sloping line. We've got price is the thing that by convention we measure on the vertical axis. On the horizontal axis, by convention, we measure quantity. Demand, then, is a downward sloping line. Downward sloping because it's an inverse relationship. What does it mean to have an inverse relationship? Well, we can think about 2 different points on this demand curve. Let's pull one point and let's pull another point. That first point on that demand curve, it has a combination of price and quantity that is associated with it. Let's call it P1 and QD1. And the second point on the demand curve has a second set of price and quantity that are associated with this. To make this a little simpler, let's call this A and let's call this B. When we say that there's an inverse relationship, what are we saying? We're saying that as we move from A to B, what's happening? Prices are falling. How do consumers respond to lower prices? They respond by wanting to purchase additional units. When prices decrease, the quantity demanded increases. We can also tell this inverse relationship going the opposite direction. When prices go up, when things become more expensive for buyers, they want to purchase less of them. That's what we mean by this concept of demand. It's very useful to think about demand in 2 different ways. Number 1, to think about demand as an individual concept. What do you want to purchase as an individual buyer? That's going to give you a lot of intuition, but from here on out, when we talk about demand, unless otherwise noted, we're going to be referencing market demand. Market demand is the aggregation or the grouping of all the individual demands for a product. We can establish a concept called willingness to pay that's very, very useful for thinking about demand. It's the underpinning of demand. To motivate this, before we motivate, let's define it. Willingness to pay, the WTP. What is it? It's the maximum amount that a buyer is willing and able to pay for a good. So we've got some key things in there. Number 1, it's an amount, but it's not any old amount. It's the maximum amount. It is the highest amount where a buyer is willing to pay for a good or service. Any penny above that amount, buyers would walk away from the transaction. This is the very highest where they would still purchase the good. They're willing to pay and ability to pay. You must have the resources in order to be able to do this. So I can posit some hypothetical information. I really like coffee, so here's my hypothetical willingness to pay for certain coffee in the morning. Willingness to pay is a marginal measure, so that means that the way I interpret this chart, this is my first, second, third, fourth cup of coffee, and for my first cup of coffee, I am willing to pay $4. For my second cup of coffee, I'm willing to pay an additional $3.90. And so on and so on. If I graphed out these in pieces of information, thinking of quantity as a measure of how many cups of coffee I have, 1, 2, 3, 4 cups of coffee, which I would like to buy, I've got a willingness to pay of $4, $3.90, and $3.80, and so on. If I looked at those different levels of willingness to pay, I could ask a question based on price. If the price of a cup of coffee was $5, how many cups of coffee would I buy? None, right? How low does price have to go before I'm willing to join this market. Prices have to drop all the way down to $4. But when prices are down at $4, how many cups of coffee do I buy? Only one. If prices were to drop all the way down to, say, $3.70, at a price of $3.70, I would purchase 1, 2, 3 cups of coffee, but not the fourth, right? So we just described an inverse relationship. As prices went down, I wanted to purchase a higher number of units. That is, my quantity demanded increases. If we plotted out my willingness to pay, and then did a nice little combination of those things with a line, in essence, what we would be measuring is the demand curve. We can make a more general statement to say that this demand curve contains two pieces of information. Yes, it tells us for a given price the level of quantity demanded. It also tells us for a given quantity how much consumers are willing to pay for that particular unit. If I looked at a quantity of 3, the demand curve is going to tell me that the willingness to pay for that third cup of coffee is $3.80. We can also talk algebraically about what's going on with our story. Again, we've said that the demand curve is a downward sloping line, so we can graph this out. The first thing we should do with every graph, if I'm really being careful, is putting label on all my axes. So I've got price on my vertical, quantity on my horizontal. I have a downward sloping line with demand. What if it was based on this specific equation of market demand, right? We've got the familiar y equals mx plus b format, except instead of measuring y vertically, I'm measuring p vertically, and instead of measuring x horizontally, I'm measuring q. But it still has that familiar structure to it. I notice that my constant term, my vertical intercept, is 50, and I know that it's a straight downward sloping line because I have a constant coefficient. I'm going to push this ahead and say I've got a horizontal intercept of 500. We can think about how did I mathematically come up with that value of 50 and 500? That 50 is my vertical intercept. Fundamentally, right, I'm measuring quantity on my horizontal axis. At this point right here, there's two values. There's a price value and there's a quantity value. That has a quantity of 0. The 50 is the value of price. That is, when quantity takes on a value of 0, price takes on a value of 50. How did I know that from my equation? How did I find that out? I found that out by positing this question. What is the value of price when quantity equals 0? Simply using my equation, so P equals 50 minus 0.10 Q, but in place of Q, I'm inserting the value of 0 and solving for P, right? And algebraically, this simplifies down to P equals 50. What's the price when quantity is equal to 0? Price is equal to 50. What's the price when quantity equals 0? That's the value of my vertical intercept. How do we find the 500? How do we find the horizontal intercept? In essence, what we're looking for is, if we looked at a price of 0, what's the value of Q that's associated with that? I can't directly identify that in my equation, but with a little bit of algebra and the same basic method, I can come up with it. Again, what we're doing is positing the question, what's the value of Q when P equals 0, right? When P equals 0, what's the value of Q that the line hits the axis? That's my question. Let's just insert this information into my basic equation again, into my little model. I'm looking for Q. I don't know Q, so I leave it as a variable. But I'm asking when P is equal to 0. So let's take 0 and put in place of P in my model 0, and then solve for Q. A little bit of algebra gets me to Q equals 500. So again, we're saying when price is equal to 0, Q takes on a value of 500. Lastly, just to make sure we've got some reinforcement of some terminology, we could ask the question, what happens to the demand for oranges when the price of oranges increases? What happens to the demand for oranges when the price of oranges increases? Nothing. Nothing happens to the demand. Demand does not change. Quantity demanded decreases. Let's go back to my basic model right here. Again, this is one of the trickiest parts, is getting this terminology right. If my price were to increase, does that line move? Nope, it doesn't. What moves? The thing that I'm measuring horizontally. When price increases, quantity demanded decreases. Demand is this line that shows many different combinations of price and quantity demanded.